Welcome to Discovering Agilent SystemVue. This is a brief module to introduce you to the basics of part wiring within the Agilent SystemVue product. The products featured in this video are the W1461 SystemVue product, which is the core SystemVue configuration for all product bundles. Let's review initially the concept of a multi-port part versus a single port part, or a multi-input part versus a single input part. So here you can see on my schematic I have two basic components, a multi-input or multi-port adder and a single input gain block. You immediately should see that the single input or single port parts have a single arrow that represents a single connection to its input versus a multi-port input which has a double arrow at its input, denoting it as a multi-port or multi-input part. The difference basically between these is in a single input part, as the name implies, only one signal or one net name is valid at the input pin of this type of component, whereas a multi-port or multi-input part, the input will actually expand to the number of inputs that are connected to it. So as a simple illustration, if I was to just draw three wires from the input of my parts, you'll notice here that on my gain block I have three wires that are all numbered with a node name of 2. If I do the same thing on my multi-input part, multi-port part, and I draw a number of wires, initially you're going to see the same thing. So here you see node 7, node 7, node 7 connected to the input to this part. However, unlike the single input part, if I now connect multiple source models or multiple wired connections to this input, you will actually see that the node names will change to reflect the fact that the input port of the multi-port part is expanding. So I'll wire this first source to the first wire, and immediately you see the node name change, so it's now picking up a node 4. Now if I do the same here and I wire this next net, you'll notice now we have a node 4 and a node 6. So now my input has two inputs, or the input to my multi-port part has two inputs. And again, if I do the same with the third component and I wire it up, I now have a new node named node 5. So now the input size of my adder has expanded to 3. And to check this, again, I can just right mouse click on the nodal pin of the multi-port part, select Edit Terminal Mapping, and here you can see the node name. So node 4, which is this first constant source, is mapped to input 1. Node 6 from my second source is mapped to input 2, and node 5 from my third source is mapped to input 3. So hopefully this will help you understand the basic connections that go to SystemVue parts. Again, as a review, the difference between a single input part and the wiring of a single input part versus the wiring to a multi-input part. Another way to wire multiple signals to a multi-input part is through the use of buses in SystemVue. So here you can see I'm starting with 3 sources, and just to distinguish these I will give this a value of 3. What I can do to make a connection through buses is I can actually start from the multi-input part and just draw a wire. And from this wire I can just double click on it and actually give this wire a bus name. So I'm going to give it a size of 3 using the syntax bus name, which is I just picked A, open parentheses, starting bus value, colon, ending bus value. So starting with connection 1 through connection 3. So this will have a bus size of 3. Now when I click OK, you'll notice that the wire thickness has increased and the wire is now noted with a 1 through 3. Now I can actually connect each one of my wires to this bus, and if you notice, this will automatically expand the bus to this wire. And then I can make my second connection, and I can make my third connection. And if you notice again, the bus has expanded to all three wires. Now what I want to do is this wire here, I want to label it A1, and then I want to label this wire A2, and then label this wire A3. And what I now have is three individual wires going into a bus feeding a multi-input port. Now if I just click the Simulate button and look at my results, I should see the sum of 1, 2, and 3, which will be 6. And here you see a value of 6. So again, just to review, another simple way to make bus or to make connections to a multi-input part or a multi-port part is through the use of bus connections. Another common wiring task in SystemVue is wiring up multiple signals or multiple wires to a multi-port input, and then making a single port connection from one of the components to a additional single port input component. So here you see a number of components that I have down, and what I want to do is I want to sum the constant with a delayed version of the constant in the adder block. So wiring up that is pretty straightforward. I can simply just wire from my constant to the summer block, the adder block, and then wire up my delay element, and then wire my delay element to the input of my adder. So you can see here that the node number on the constant is node 7, and the node number on the delay output is node 5. And if I was to look at the terminal mapping on my adder, you can see here that input 1 is mapped to node 7 and input 2 is mapped to node 5. Everything's fine. If I run this simulation, I should get the expected result. Now, however, what if I want to take, in addition to this, wire the output of my delay to the input of another block? I might simply just look at my schematic and say, well, the output of my delay is here at the input of the summer, so I'm just going to go ahead and wire that up to my delay element. But notice now that what happened is the gain block actually picked up node 7, which is the node that goes to my constant block. So in fact, it's not actually the wire that I expect. So the way to wire this properly would be to either ensure that the gain block is in a place where you can conveniently wire it directly from the output pin to the input to the adder, or the input to the gain block, or you just simply have to route the signal from the output, directly from the output of the delay element to the input to the gain block. So this wiring will ensure that the net name or the node number is actually mapped correctly to the single port input.